is video 8C. We're going to take everything we learned about stoichiometry from video A, limiting and excess reactants from video B, and add one last thing with theoretical and actual yield to it, and then we're finally done with this unit. So theoretical and actual yield, as we said before, most reactions do not go to completion. Why? Because one of our reactants runs out. So our theoretical yield, this is yield of product, is exactly how much product we should get if the reaction proceeds as planned. So we'd love to have 100% yield. But sometimes our actual yield is less than what we should have produced. We're going to try this in the lab. If you're back in the lab, maybe you spilled something or you didn't measure something properly, but the actual yield is the amount of product that is actually produced. These are usually your laboratory results. So how do I calculate percent? Percent Y, percent yield, equals the actual, usually in grams, yield, divided by the theoretical yield, again, divide by grams, grams over grams, actual over theoretical times 100. So we're going to do two examples from start to finish, balance the reaction, figure out the limiting and excess, and then calculate the percent yield. If you'd like to pause here, I'm going to go into the balancing the equation. I'll write the balanced equation, see how much you can do, come back, double check your answers with me, and save part E to the very end, and then we'll go over that one together. So, same thing. Solid copper reacts with silver 1 nitrate in a single replacement reaction to form solid silver and copper nitrate solution. Part A, exactly the same. Write a balanced equation. Solid copper reacts with silver nitrate, plus 1 minus 1, in a single replacement reaction to form solid silver and copper, this time 2 plus nitrate, CuNO3, 2 solution. To balance this, I'll need 2 nitrate groups, which means I need 2 silvers. 1 to 2 to 2 to 1 would be my ratio. Starting with what we did back in the limiting reactant part B, I'm given 125 grams of copper. That's how much I have. This is my have. And I also have 429 grams of silver nitrate. First, figure out which reactant runs out first. So, where do I start? I can start with either one, right? I'm going to start with the first one, just because it's written first. 125 grams of copper. I still want to do the exact same thing, converting from grams of copper to grams of silver nitrate. Grams to moles, mole ratio, back to grams, same 3 steps. If I'm in grams of copper, I need the molar mass of copper. Looking at the periodic table, it's 63.55 grams per 1 mole. My ratio is 1 to 2. 1 mole has to go on the bottom because I need to cancel out copper. 2 moles of AgNO3. I didn't want to get to moles. I need one more step. I said it was 3 steps. I need to get to grams. So 1 mole of silver nitrate, again looking on the periodic table, is 169.88 grams. When I calculate that out, that gives me 668.3 grams of silver nitrate. That's my need. Comparing that with my have, this time my need is greater than my have. When your need is greater than your have, This one has to be my limiting reactant. Silver nitrate is my limiting reactant. If silver nitrate is limiting, that means I must have excess copper. So, part C, with the amounts reacted in part A, how many grams of silver can I make? Silver is my product. How many grams of silver can I make? This is where I must start with what I have of my limiting. Since it's going to run out first, who runs out first? Silver nitrate. Which number do I pick? The 668 or the 429? You have to start with what you have. So I have 429 grams of silver nitrate. I want to calculate that to grams of silver. Again, grams to grams is a 3-step FLM problem. I need the mass of silver nitrate, which I had before as 169.88, and that gets me to 1 mole. This time my ratio is 2 to 2. 2 moles AgNO3 gives me 2 moles of silver, but I didn't want to be in moles. I have to get to grams. So 1 mole of silver, looking at the periodic table, is 107.87 grams. Calculating that through, I am able to make 269.9 grams of silver before my silver nitrate runs out and my reaction is over. Part D, how many grams of the excess reactant will remain unused? Well, since I picked the wrong one, and this just happens by chance, I didn't calculate how much I needed. So now I have to go back and do the reverse. Instead of starting here with copper, I have to start with this guy, right, because he's going to run out first, my silver nitrate. I have to start with 429 grams of silver nitrate. I'm going grams of silver nitrate backwards to grams of copper. So I need the molar mass of silver nitrate, we said was 169.88 grams in 1 mole. And since I'm going backwards, I still need the 2-to-1 ratio, but instead of 2 being on top and 1 being on the bottom, now I have to flip it. Two moles of AgNO3 is equal to 1 mole of copper, and then to get to grams, 1 mole of copper we said was 63.55 grams. So how many grams will remain unused? First I have to figure out how many I actually need. And I need 80.2 grams of copper. That's how much I need. How much excess did I have? Again, we said excess was have minus need. Going back to part B, I have 125 grams of copper total. 125 grams total, but I only needed to use 80.2. That tells me I have about 44.8 grams of leftover extra. Now, part E. This gets me to my percent yield. I'm calculating percent yield. yield we said was actual over theoretical times 100. If 255.5 grams of silver are actually produced, this must be my actual. I put that on the top. 255 grams of silver are actually produced. I need to find my theoretical. I calculated my theoretical somewhere, so I need to go back and find the grams of silver, which we calculated in part C. I should have produced, this is my theoretical yield. Theoretically, if my reaction went 100%, I didn't spill anything, there were no errors, I should have produced 269.9 grams. I did okay. Not quite 100%. Dividing those, multiply by 100 to change it into percent, I did pretty good. I got 94.6%. I got an A. I didn't spill too much. It's a pretty good percent yield. Okay, I'm going to go into example number 2, doing the same thing. Again, if you want to pause it here, try as much as you can, then you'll know exactly where you have questions to come back and ask me. First step, writing the chemical equation. Silver 1 nitrate, now we have silver nitrate again. This time it's reacting with iron 2 chloride, This is a double displacement reaction. In a double displacement, we have our double swap. So my iron and my silver are going to switch places. So I'm going to get Ag, which is a +1 Cl, and iron, Fe. Fe was a 2 plus, NO3, 2. Balancing that, I need a 2 over here for the nitrates. That gives me 2 silvers. 2 here gives me chlorine. My ratio is 2 to 1 to 2 to 1. It's my balanced chemical equation. Now, which reactant is the limiting reactant? Okay. I'm given 2.5 grams of silver nitrate. Here's what I have. 2.5 grams of silver nitrate and 4.5 grams of iron chloride. Again, I just start with the first one. 2.50 grams of AgNO3. Converting grams to grams. 3 steps. Grams to moles, mole ratio, back to grams. My silver nitrate mass was 169.88 grams in 1 mole. Now for my mole ratio, which is 2 to 1. The 2 has to go on the bottom, because that's the number in front of silver nitrate. FeCl2 on the top, canceling. And then 1 mole of FeCl2, looking on the periodic table, is 126.75 grams. When I calculate that out, I get 0.93, how many sig figs? 3 sig figs, 933 grams of FeCl2. This is my need. Comparing my need to my have, I have 4.5 grams. This is obviously my excess reactant. So if this is my excess here, silver nitrate must be my limiting reactant. So part C. What's the maximum number of grams of AgCl? This is my product, so this has to be my theoretical yield that could be obtained from this mixture. What do I have to start with when I calculate products? I have to start with my limiting reactant and how much I have of it. We said silver nitrate was my limiting, so now I'm converting silver nitrate to silver chloride. That's a 2-to-2 ratio, but I have to start with my grams, which was what I was given. 2.50 grams of AgNO3. Again, grams to grams, 3 steps. I need the molar mass, 169.88 grams of silver nitrate is in 1 mole of silver nitrate. Mole ratio, we said 2-to-2. 2 mole AgNO3 equals 2 moles of AgCl, but I didn't want to get to moles. I need to get to grams. So my final step, 1 mole of AgCl, looking on the periodic table for the mass, is 142.32 grams of AgCl. Punch that in your calculator. You should get 2.8 grams of AgCl. That's my theoretical yield based on the limiting reactant of 2.5 grams of silver nitrate. Part D, how many grams of the reactant in excess? Again, excess equals how much I have minus how much I need. This time I did the right calculation because I figured out that iron chloride was my excess. It says I have 4.50 grams. Have is 4.50 grams minus, what did I need? 0.933 of FeCl2. So my excess FeCl2 is 3.57 grams in excess. Now, here's the last step, percent yield. If the percent yield is 87.9%, now it gave me the percent. That's equal to actual over theoretical, remember, times 100. How much AgCl was actually produced? Here I'm solving for the actual. I calculated my theoretical back on the other page. So 87.9% equals A over, theoretically I should have produced, 2.8 grams. So if it was 100%, I would have produced 2.8 grams, but I didn't. 87.9%, I lost a little bit. If you rearrange this algebra, divide both sides by 100, you get 0.879 equals A over 2.8 grams. 2.8 times 0.879 would get rid of this as my denominator, and my actual yield is 2.46 grams of AgCl. So you can see now I can give you the percent yield or the actual, and you calculate the other one. The theoretical yield will always be calculated in a question above, like the part C that we did before. We'll do lots more practice of this on the worksheets. Write down your questions. Let me know what they are. We'll go over it. We'll do more so you get comfortable with these kinds of mole calculations plus the limiting reactant. And the final piece is the percent yield equation.